All right, let's get into it. If you're gearing up for that AWS developer exam, you absolutely have to know EC2 inside and out. Today, we're going to master the big three, using IAM roles the right way, automating everything with user data, and managing your instances like a pro. Let's do this!
Okay, let's kick things off with a classic problem, something you are guaranteed to see on the exam, and frankly, something you still see out in the real world way too often. A developer sticks their AWS access keys right into a script. Yikes. That is a huge security no-no. So, what's the right way, the secure way, the way AWS wants you to do it?
And here's the core of it, right? You've got two choices. On one hand, you have hard-coded keys. Think of these as a permanent liability. They live forever. And if they ever get out, like someone accidentally pushes them to a public GitHub repo, it's game over. Your account is wide open. Plus, you have to remember to rotate them yourself, which, let's be honest, is a real pain. But then you have IAM Roles. This is the smart way. They give you temporary credentials that AWS rotates for you automatically. It's like, instead of hiding a key under the doormat, you have a smart lock that creates a new, temporary code for anyone who needs to get in. It's just so much better. Okay, so let's dig into that secure foundation. We're talking about IAM roles, and really getting how these work isn't just about passing the test, it's about building things the right way, securely from the ground up.
So what even is an IAM role? I like to think of it as a special hat. It's not a person, like an IAM user. It's a hat that gives whoever's wearing it specific powers, or permissions. The key thing is, the hat doesn't have its own permanent password or keys. It's meant to be worn temporarily by things you trust. And in our case, the trusted thing is our EC2 instance.
Right, so how does our EC2 instance actually put on that permission hat? Well, that's where the instance profile comes in. You can think of the instance profile as the thing that actually holds onto the role for the instance. It's like a wrapper. When you're launching an EC2 instance, you're not actually attaching the role itself, you're attaching the instance profile that contains the role. It's a small detail, but it's super important for the exam. And this is where the magic really happens. Your app is running on EC2 and needs to call an AWS API. What does it do? It doesn't look for a file with keys. No way. The AWS SDK, under the hood, automatically calls this special local address, this instance metadata service. That service then looks at the instance profile we attached, and poof, it hands back a fresh set of temporary credentials. There's no hard coding, no managing files. It just works. It's secure and totally automatic.
And this whole system is super flexible, too. It even works for tricky stuff like cross-account access. Say your EC2 instance in account A needs to grab a file from an S3 bucket in account B. Simple. You just give its role permission to assume another role over in account B. It's a really clean, secure pattern you'll see a lot.
All right, so we've nailed down permissions. That's a huge piece of the puzzle. But what about getting the instance ready to do work? How do we install our software and get everything configured, automatically right when it starts up?
So think about this scenario. You need to launch, say, 10 web servers. Are you really going to SSH into every single one, run apt-get install nginx, clone your Git repo, and start the service? I mean, you could, but no, just no. There's got to be an automated way to do this, right?
Of course there is, and it's called EC2 user data. It's beautifully simple, really. It's just a script, usually a shell script, that you give to EC2 when you launch it, and AWS takes care of running that script for you automatically the very first time the instance boots up. You can do anything in there. Install packages, download files, configure services, you name it.
Okay, two things you absolutely have to burn into your memory for the exam. Number one, the user data script runs as the root user. That means no more typing sudo everywhere in your script. Nice. Number two, and this is the one that trips people up, by default, it only runs one time on the very first boot. If you stop and restart that instance, the script is not going to run again. That's a classic exam question.
This leads to a really important strategic choice you have to make as a developer. Do you put all your setup logic in a user data script, or do you pre-bake everything into a custom Amazon machine image, an AMI? An AMI is like a perfect pre-made template of your server, a golden image. It's awesome for what we call immutable infrastructure, where you just swap out old servers for new ones. User data, on the other hand, is all about dynamic, on-the-fly configuration at launch. It's way more flexible if you need to make frequent changes. Okay, so we're using IAM roles for permissions, and we're using user data for setup. That's great. But what happens when your setup script needs something sensitive, like a database password or an API key? We've created a new problem for ourselves. And please, whatever you do, do not do this. Just pasting a password or a secret right into your user data script, that is a terrible idea. It's just as bad as putting it in your code. Anyone who can see the instance details in the console or through the API can see your secret in plain text. It's a huge security hole.
So here's the elegant solution. We're going to bring our two ideas together. First, you take that secret and you store it where it belongs, in a secure service like the AWS Systems Manager parameter store. Then, you use the IAM role we already created to give the instance permission to read that secret from the parameter store. Now your user data script is clean. It has no secrets. It just has a simple command to securely fetch the secret when it runs. This is the pattern. This is the right way to do it.
All right, last piece of the puzzle. Our instance is running, it's got the right permissions, it configured itself automatically. Awesome. But now, how do we actually manage it? How do we interact with it securely day to day?
Here's a fun one. How does an application running on an EC2 instance know anything about itself? Like, how does it find out its own instance ID to use in log files, or its own public IP address so it can tell another service where to find it? How does it get that self-awareness?
Well, the answer is a service we've actually already talked about, the Instance Metadata Service. Your code can just make a simple web request to this special, local-only IP address, and voila, the service will just hand back all sorts of useful info about the instance itself. That's how it securely learns about the world it's living in.
Okay, let's talk about logging in to fix something. The old school way is SSH, right? That means you have to open up port 22 in your security group, you have to deal with SSH keys for all your developers, and auditing who did what is a mess. But then there's the modern AWS way, Systems Manager, Session Manager, and the difference is night and day. With Session Manager, you have 0 open inbound ports. Access is controlled by IAM, just like everything else, and you can log every single keystroke for a perfect audit trail. It's a game changer. So I'm going to say this as plainly as I can, because this is an exam question. If you see a question that asks for the most secure way to get a command line on an EC2 instance, the answer is not SSH. The answer is AWS Systems Manager Session Manager. It completely gets rid of the need for bastion hosts, for open ports, for managing SSH keys. It's just a massive security upgrade.
So there you have it, the whole life cycle. We secured permissions with IAM Roles, we automated the entire setup with user data and parameter store, and we have a modern, secure way to manage it with Session Manager. You've got all the building blocks now. So the only question left is, how are you going to take these patterns and make sure the next thing you build is secure right from the very start?